Dear students, good morning to one and all present here. Good morning to all. I am Dr. R. PREMSUDHA. I am going to start the yes, subject water supply and wastewater engineering. So R21 regulation, third year class, second year, third semester. So earlier this subject is called as environmental engineering. So here I am sharing the course data sheet. It consists of syllabus. Here you can see the syllabus. So the first unit it covers water supply. So the first unit introduction, water supply. So here you can see the estimation of surface water and subsurface water, predicting demand for water and impurities present in the water, physical, chemical and biological analysis, waterborne disease. And this in this here water supply and wastewater engineering the subject 3 units we are going to study about the water, how we are getting water and where we have to collect the water. After collection we have to treat the water before distribution. So in the first unit full and full we are seeing about the water demand, where we have to collect the water and how to collect the water and what is the characteristics of water. And the next is water treatment, second unit. Here you are going to see about the various unit operations and process required to treat the water, to remove the impurities, physical, chemical, biological impurities, and to make the water fit for drinking. And the third unit, it consists of water storage and distribution. So after once the water collection, after treatment, you have to distribute the water. Before distribution, after the treatment, you have to store the water. So here you can see the water storage and distribution. So what are the units required for storing and what are the network required for distribution and the various types of network. Here you can see we need the pipes and pumping, how to lay the pipes, how to connect the pipes, what are the pipe appurtenances required, everything we are going to see in this unit. And the fourth unit is sewerage. Once the water is supplied to the houses, where that water is comes as the wastewater. So how to collect that we call as sewage. The system which collect the sewage is called sewerage system. So here fourth unit is planning and design of sewerage system. So what are the characteristics of sewage, composition of sewage, how sewage is coming, that is the source. So here we are seeing only the wastewater comes from the houses. Then after collection of sewage, how to treat the sewage before distribution. That is your fifth unit. So the water supply and wastewater engineering. So here we are going to see about water and wastewater engineering. These are all the textbooks. Can refer this textbook, standard textbook, S.K. Garg, Santosh Kumar Garg, Kunmaya, and these are the reference book. So the course objective here you can see to introduce the students to various components, design, you can able to design the water supply scheme, water treatment method, water storage distribution method system, and the sewage treatment and disposal and design of in-state structure and sewerage system. Then here you can see the course outcome. So there are 5 course outcomes. Once if the students, once if you study this subject, what will be the outcome? So the first outcome, CO1, is here comprehend the different elements of water supply system, characteristics of water, design of intake structures, then and conveyance system for transmitting water. So if you study this unit, you can able to identify the different elements in water supply system, uh, then find out the characteristics. You can able to design the intake structure and conveyance system for transmitting water. And develop second unit, second CMO, develop analytical skills and design physical units of water treatment plant in construction, operation, and maintenance aspect. Then, third course outcome, demonstrate the principles, design of water supply in buildings and develop the water distribution network system. Then, fourth unit, design effective sewer system including gravity and pressure sewers and incorporate pumping stations where necessary and analyze the characteristics and composition of sewage and apply this knowledge to estimate the sewage generation rates. Then CO5, interpret the sludge analysis and design the sludge treatment process and apply the knowledge for dispose sludge in proper way. So here you can see the course outcome versus POS mapping. Then here you can see the COPO mapping justification. So if you study this first unit, you can apply the knowledge in the calculation of predict the future population. So I marked in the PO1, I gave strong correlation, and PO2 and PO4. Here you can see you can conduct the investigation of complex problem. You can able to design the water supply and treatment units. Then in PO7, I gave strong correlation. Here you can see that integrate sustainable practice in water management, including the reuse of treated wastewater and energy efficient system. And PO8, this apply the ethical principle and norms to design water supply and water treatment units. And PO9, individual and teamwork. Students can effectively work as an individual and as a member in team to do project, analyze the surface and subsurface water quality. So here student can able to how to collect the water, find out the characteristics. So I gave the correlation here and CO2 mapping with PO1, PO2, PO4, PO7, PO8 and PO9. You all know the program outcome for all the department as per NBA norms. There are 12 POs. For our department, there are 2 PSOs, program specific outcome. Then course outcome is 5. Now I'll start the unit here. Before this subject, we called as environmental engineering. What are all the things surrounding us? Here you can see the interaction. I'm going to start with the introduction. Need for protected water supply, objective of public water supply system, types of demand, per capita demand, then factors affecting per capita demand, prediction of population. So these are the topics I'm going to explain. This is in the first unit, first chapter. So what is meant by environmental engineering? What you know about the environment? Here you can see environment means what are all the things surrounding us. What are all the things surrounding us? Air, water, food, heat and light. Then what is mean by contamination? Contamination means if the water or any food is contaminated means it affects the health effects in human beings and animals. So in the ancient days, we don't have the water supply system. Public people will go long distance to carry the water. See here you can see in this picture. So no water supply system, people took water from far distance. Water is in contaminated state causing health problems. So without proper treatment, where the water is available, they will collect and they will use for drinking and cooking. So here you can see the picture in the contaminated water means it consists of bacteria and virus. It causes health effects. So where people will collect the water, people used to collect the water in lakes, rivers, ponds for their water supply. In the time of less rainfall, the scarcity of water. So during fire breakout, water is needed to put in down fire. Even fire accident occurs, we need water to put out the fire. A good public water supply system supplying safe and wholesome water is there. So what is meant by good public water supply system means it supply the safe and wholesome water needed. So this picture shows the fire demand water for so water required for firefighting also. What is the need for protected water supply? So water gets contaminated due to animal and human waste, sewage crossing the waterborne diseases, cholera, typhoid, dysentery. So once if the water is contaminated, if we intake that water, it causes disease like cholera, typhoid, dysentery. So public water supply protects the source of water from impurities like bacteria, chemical sewage, and industrial effluents. Public water supply also purifies the contaminated water to make it usable for drinking and other purposes. So here you can see the picture of raw water treatment plant. Okay. What is the objective of public water supply? To supply the safe and wholesome water to the consumers. That means unpolluted water, water free from impurities and toxic substance. Then to supply water in adequate quantity. So how much quantity of water required to a community, that much it has to supply. Then to make water easily available to consumers to meet all their needs. This is the objective of water supply system. Then coming to water demand. What is meant by water? Demand for water. The amount of water required by the community for various purposes is called water demand. So how much water is required for one person one day? That is called water demand. Like that, what are the purpose we need the water? That is called the demand. So here you can see the types of demand. There are five demand. First one is domestic demand, industrial and commercial demand, public demand, fire demand, and demand for compensating various sources. Are five types of demands. Here you can see one by one. What is meant by domestic demand? The water required for actual household purpose is called domestic demand. So what are comes under domestic demand? Drinking, cooking, bathing, washing, flushing, water closet, etc. In India, as per ISO 1172-1983, it is given in ISO the domestic water required for one person 135 liters per capita per day for a developing countries. In developed countries, this value is 350 liters per capita per day. So for developing countries, one person required 135 liters per day. In developed countries, 350 liters per capita per day. See here, you can see the picture. It's showing the man which require water. See, here you can see Here you can see various types of device. Here you can see the picture showing water demand. And the domestic demand. So what are the purpose we need the water and how much quantity is required for various activity. Here you can see in this table for drinking 5 liters per capita per day and cooking 5 liters per capita per day and bathing 50 liters per capita per day and cloth washing 25 liters per capita per day and utensil washing 10 liters per capita per day and house washing 10 liters per capita per day and Latin and Uranus 30 liters per capita per day. Totally 135 liters per capita per day. Here you can see industrial and waste demand, industrial and commercial demand. So water required for various industry depending upon the process, manufacturing process, cooling process, and steam regeneration. So where the water required, it varies from the industries to industries. And water required for private office, restaurants, hostels, schools, cinema theaters, as well as commercial demand. So industrial demand means required for industry for various purpose and the commercial demand means the public using places. And here it is given for each factories, restaurant, how much water is required. So what is the demand? For factories, if you say 30 to 45 liters, and office 45 liters per capita per day, and the restaurant seats 70 liters per capita per day, hotels per person. So for restaurant per seat and hotels per person 180 liters per capita per day, including boarding and lodging. In cinema theaters per seat 50 liters per capita per day. And public demand. So here it is showing the water required for public purpose such as washing of roads, cleaning, public sewers, watering of parks, public gardens, fountains, flushings of public water closets, and urinals, etc. is known as public demand. In the public garden, it requires 1.5 liters per square meter per day, and street washing 1 liter per square meter per day, and sewer cleaning 4.5 liters per capita per day. The fire demand, so water required for the local body to protect the property and human life from the fury of fire is known as fire demand. It is, how much water is required for fire demand is calculated by the population data by using this following formula. Kuchling's formula. There are four formulas: Kuchling's formula, distance formula, National Board of Fire and the Writer's formula, then Freeman's formula. Then demand for compensating various losses. So wastage in pipeline and defective in pipe joints, cracks, faulty valves and fitting. So wastage in pipeline. Due to this, we need the water and careless and lazy habits of consumers and inefficient management. There is a loss, tips and unauthorized water connection. So persons in the roadside you can see without permission they illegally they take the water and used for construction or cleaning purpose, cleaning the cars, buses, lorries, like that. So the allowance of 50% of total quantity of water to compensate these losses to protect the water table. Here you can see in this picture water losses due to faulty workmanships or leakage, but people not closing the pipe properly. And this is the formula to find the pipe demand. And here one more. Put out examples by using this formula. Here you can see this formula, Michelin's formula, Q equal to Q is rate of flow, 3182 square root of P. P is nothing but present population in thousand, and F is number of simultaneous file streams. So here it is given the population 1,70,000 in thousands. So Michelin's formula is 318 square root of P. You see how much water required. So like that, you can solve this problem by applying the formula and substitute the values. You'll get the how much water required for fire demand. What is mean by per capita demand? So the consumption of water for one person in one day is called per capita demand. So the demand is water required for various purposes, but per capita demand is consumption of water per person per day. So per capita demand equal to Q divided by P into 365 liters per day. That means population into 365 days we need the water. And next, coming to factors affecting per capita demand. Here you can see there are 11 factors which affect the per capita demand. See, based on the people habits, industrialization, public service, climate, system of supply, metering of water supply, system of drainage, availability of supplementary sources, distribution pressure, cost of water, quality of water. So here you can see people's habits. People with high standard of living require more water than those belonging to middle class and low income groups. So high standard people require more quantity of water because they provided pipeline in all the places in their house. So more number of toilets, more number of wash stations, more number of luxurious things, fountains, swimming pools they will have, so they require more water. In industrialization, the requirement varies from industries to industry. Wet processing industry require huge quantity of water. Public services, developed cities, towns, and townships require more water for watering of parks, gardens, and roads. Then climate, people living in hot climate areas require more water for drinking, then for bathing, then for washing their clothes, they need more water. The system of supply. So the supply is continuous. That means 24 hours supply means compared to intermittent supply, the wastage will be more. Then metering. If the meters are used and consumers are charged, the consumption of water will be reduced. In system of drainage, the existence of sewerage system consumes more water for cleaning. In case of Indian toilet and Western toilet, if you take the flushing system requires more water. Availability of supplementary source. If the well is available, used, then municipal water supply will reduce. If there is no another option, then the demand will be more. Then distribution pressure. If the pressure consumption of water is more in high drainage pressure due to more wastage in taps. Then cost of water is high means consumption will be less. Then quality of water. If the quality is good and the people will not use the other source available, so like wells and pumps, hence the demand will be more. So with this, I'll stop. What all we have seen once I'll recollect. So first we saw the course syllabus, course outcome, and the COPO mapping. Then I started the first chapter. So what is the need for public water supply system, and what is the objective for public water supply system, then what are all the various types of demand, then factors affecting per capita demand. Okay, these are that. The next class I'll start the how we'll predict the population, how to calculate the future population for the supply.